A first format is here somewhere 200 hertz, but here it is somewhere 350 hertz. There also slight difference is there. Second format difference, third format comes here, but here almost fourth format comes in place of, in the case of fine. So based on what we are speaking, if you take a spectrum of that speed signal, what we see different positions and energies of spectrum. Those are called as formal frequencies. This we need to understand. So these are the different formal frequencies. See here. This is E. This is F1 value 270 hertz. F2 value 2290 hertz. F3 value 3010 hertz. These are the formal frequencies of male voice. Men, women, these are the formal frequencies. Children, these are the formal frequencies. Means if a male person pronounces E, if you take FFT of that signal, formal frequencies observed like this. Fine. If it is E, then these are the formal frequencies. See, there's a change. F1 here in case of E is 270, but F1 in case of E is 390. A, this is O. Likewise, all formats are there. So, and again, formal frequencies for male and female are different. F1 for men it is 270 for E, for women it is 310, for children it is 370. Right? So, formal frequencies play a major role in deciding which phoneme is being spoken. Right? So, that is what the combination of 270, 2290 and 3010 tells that O is being spoken by male. It's where our brain deciphers what it is hearing. So it gets all information about all the frequency components through cochlea. You were hearing in the beginning. So through cochlea, it knows that 270 is a higher frequency, 2290 is a higher frequency, 3010 is a higher frequency. Then the phoneme corresponding to this is heard or is heard. Right? Similarly, to produce these frequency components, your articulatory organs are moved in case of speech production. It is speech perception, hearing. Mainly these formal frequencies are very dominated in case of vowels, not in these consonants. In vowels, these are very dominant. That's what only vowels I have taken here. These are vowels. And this is well established research. It's not what we have done. Long back, maybe some 10, 20, 30 years back. All these things are done. And it's very clearly known to everyone who is processing speech, doing work on speech processing. They know all these things. These are very basic things. On top of this, we need to build something new based on our applications. So this is F1, F2 plot. We call it as F1, F2 plot. These are F1 frequencies. These are F2 frequencies. If you take each voice sound unit and if you plot their F1 and F2, likewise you see clusters. For A, this is the cluster. For O, this is the cluster. For O, this is the cluster. Means we have overlapping clusters. Means very clearly, because while we speak, I pronounce ow, someone will pronounce ow like that. So there will be differences. So these differences lead to these overlaps finally. Fine. Okay, but now majority of these things we have already explained. So what are the issues? What do speech processing scientists do? What are the problems that they try to solve? One is speech coding. This we did not touch. Speech coding. Why do we do coding? When do we do coding? Coding of anything. Which coding method did you hear about? Any coding method you have heard about? Yes. MP4 file. Then what we teach in our classes? Any coding did you teach in the class? ASCII code, No, ASCII code, ASCII code. One more is BCD, and 8421. All these are different coding techniques. What do we do by coding? Storing is easier. Storing is here, and A we cannot store. This validation. A we cannot store directly. So represent this A using some numbers. Because computers can store only numbers. So representing B using some numbers. Representing equal sign using some numbers. That's coding. Likewise, speed signal also has to be coded. Because once, especially this is used in telephone communication. So whenever I speak on a telephone, speech signal cannot be directly transmitted, cannot be sent directly. Speech signal at the source side converted into some numbers. These numbers are transmitted because all digital technology is only about processing numbers, either storing numbers or forwarding numbers or communicating numbers, whatever it is, only numbers. Even red color is also communicated using some number. You know all those things, isn't it? So I speak here, speech has to be sent to other side, so it has to be converted to numbers, then those numbers can be sent, again the speech has to be reconstructed there, and that person hears it. So this conversion of speech into some numbers is called as speech coding. That is the first work. Second is speech synthesis. Somebody gives us a text, then your computer is converted into speech. That's called as text to speech. Speech synthesis, TTS. Similarly, you have STT, speech to text, that means speech recognition or speech understanding. Whatever I have spoken, computer should understand that. It's converted to text. Because text processing is done earlier to speech processing. We are almost converted in text processing. Because text representation, everything is very well studied and we know those techniques. So converting speech into text is speech understanding or speech recognition. Text to speech is speech synthesis or speech generation. So those things people are working on. Then speaker recognition. Who has spoken? I told banking example. I have given identification of the speaker by means of voice. So that is one more issue. Speech enhancement. I spoke about noisy speech. You are talking, noise is there. You want to suppress the noise. Now there are so many noise suppression tools. Isn't it? While you in performance microphone, while singers are singing, it will not capture the noise. So technologies are designed. That is called enhancement, speech enhancement. Suppression is something what you do before recording. Enhancement is already you have recorded some noise is there and you want to remove that noise. That's called as noise enhancement. That activity people are doing. Then language identification, which language particular person is speaking, that we can do in the English, what language is speaking. Then emotional recognition, we can do emotion of the person. Once I speak, then I am happy emotion of bad mood. Then that. You are very happy, not good for your heart, to cool down. You are very sad, so you have to rejuvenate. Some instructions you should get. So emotion processing, age and gender identification, that also we have discussed earlier. Then audio engineering, very big area of research. Audio engineering is there, where mixing of different instrument voices and modulating them, which gives better effect. All this fast effect and all we addressed in our layers. This becomes audio engineering. Then we have support for abnormal children studies. Normally, teacher teaches in a single platform, irrespective of seeing students' requirements. Many forums we say that student-centric learning. We are not doing student-centric learning. We are doing still teacher-centric learning. I know this way I can teach, I will teach. And irrespective of whether you are 99 percentile or 40 percentile, you have to adjust to my teaching. So you can use this technology and support that person who is slow learner. That kind of applications are also possible. And that's what speech coding is, speech compression. Speech is very lengthy signal. If you depends upon sampling rate. If you store 44,100 values per second of speech, how many bits do we use normally to store one integer? 8 bits. 8 bits are sufficient. 16 bits we use. 8 bits is 2 to the power 8. 2 to the power 8 is 256. Maximum number can be present is only 256. Or we have number lakhs, crores, isn't it? 16 bits or even more number of bits we use. 32 bits we use. Let us assume 32 bits we use. 32 bits into 44,100 numbers per second. Those many values per second. And I'm speaking 1.5 hours. You want to record this speech, huge storage you need. So speech compression can be there. Can we compress the speech? MP3 is one such compression technique. MP4 is one such compression technique. So we use that, and that's also a research area. Those are called as speech coding techniques. Let us not go into the details of this because this is not exactly what we are doing in this lab. Don't worry about this. This is again coding. Speech synthesis. How do we produce a speech? A lot of slides are there still. I want to. Okay. Something this you will be doing now in this lab. Speech signal as a physical signal has got certain properties which are related to the way human beings produce their speech. Say, for example, um, majority of the cases, human beings understands who is speaking or what is speaking based on prosodic features. We call them prosodic features. One prosodic feature is energy. How loudly I am speaking. That's energy. We call it energy, intensity, different names. How loudly I am speaking. That loudness, if you hear, you can tell that this person is speaking. That is one feature. Another is intonation. We call it intonation. What pitch I am speaking. What pitch value I am speaking. What is pitch? Have you heard about this word pitch before? Any singers are here? Who have formally learned to Canada. How is pitch value? I know. I know. That's I know. I know I know stop sorry I know I did to sorry whenever you say example sir is go sir what is this frequency pitch frequency is fine frequency anything important all these have said in a mountain no not all this you shout more it may change but it's not correct it is not all this morning you have studied that what is it it is how many times your vocal folds vibrate. These are not working in speech. The areas are different. So morning is that our vocal folds close, open. How many times they close and open in 1 second? That's not a speech. It is involuntary activity. Normally, it is voluntary activity. Involuntary is we are not under control. Not control. But good musicians, good singers, they control it. That's what Madam was saying. It's the low pitch where the says, high pitch me, that come out of high. High pitch means they voluntarily control vibrations of total force, then they become good singers. This is something related to pitch. But coming to, what is your opinion about male? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 men are there. 1, 2, 3, 4, 5 men are there. You see, you can take a majority. India is the majority. Whose pitch is more? You can't say the comparative analysis. Female pitch is more. Female pitch is more. As pitch increases, voice becomes more melodious. Voice becomes more melodious. So, female voice is more better, right? All of us agree. Not in home of your practice. So it's and females need not be proud of that. What about children's speech? Still higher. Still higher. So normally male pitch used to be in the range of 80 to 130, 140, like that, 140 hertz per second. Female pitch used to be 150 to 250 to 80 hertz. Children pitch used to be more than 300 hertz. Right? So that will be seeing now. That will be hard to compute and see, but record the voice to take your pitch. So what is this sound? Pitch is one more prosodic feature. Energy is one prosodic feature. And duration. How much time do I take to pronounce one vowel or one word? Some people do speech slow. The duration of the speech is more. That is one more prosodic feature. So these prosodic features only will be modulated by the mimicry feature. Those who do mimicry, they only change this prosodic parameter of the speech to make them hear like somebody else. But computers will not do that. Computers will go one level down. They extract that mathematical details. Where very clearly will be able to understand that even if it is not the original. Right? Somebody asked that question, you asked this. Let's answer for that. So rhythm is one more prosodic feature. Then timbre. Have you heard about timbre? Timbre of a speech. Each single line is or her own timbre. Timbre is a voice quality of a person. So it is individual voice quality of a person. It is individual. It is not hard. That is one more prosody. If we are able to access or extract these prosodic features, we can do certain tasks like identifying whether the person is male or female. Because mainly gender, using the pitch, we can very clearly discriminate gender. Whether it is child or what. Those things we can do. Different things, don't worry. Just I will tell one thing related to speech synthesis, how computers synthesize speech. Have you heard anywhere the computer synthesizing speech? The speech is generated by computer. Have you heard anywhere? All of you have heard. I know. Customer care, yeah. Many other examples. Customer care is not exact example. Many other things. Voice chatting. Voice chatting is like that. Then, more frequently, railway station announcements have got, yeah, that number of the platform, it will be a number, whether it is late or not, coming or not, that they announce. Is it natural speak? Are you feeling that, or do you feel like it is more appealing to us natural or to what is the problem there? It's we don't travel by day or what? If it is natural, they should say platform number 4. It is like 4. A number hidden. Okay, that's one thing. That is based on my age. The different patterns pattern and that. Correct. Very good. That is a good observation. This is a outcome of that observation. That is not a natural speech as human beings speak. Somebody might have spoken, they have divided that into some words. Those words are stored separately, and whenever there is a need, they take one word. They take one word from this data set, one more word from this data set, they concatenate them, they keep them around together, and they pronounce it. The person who is speaking great number might be speaking slow. The person who is telling a platform number might be loud enough. So that's what sometimes we hear it very loud, sometimes we hear it very feeble. So that is part of concatenative speech synthesis. Third one. Concatenative speech synthesis. Concatenation may be word concatenation. Two words will take a concatenation. Concatenation will be phonic concatenation. Phonics will take a concatenate. And during concatenation, there will be a lot of problems. As I said, prosodic values will be different. Once I speak, my prosody is almost the same. You have understood it. Either it is fast, it's always fast. If it is slow, it's always slow. But there it's not like that. This person had spoken fast, this person has spoken slow, and you are combining them, concatenating them, then playing it. That's what we don't feel it as natural. Still, it's a human generated voice, but sentence is generated by computer. Right? But there are some sentences, some speeches which are totally generated by machine only. Robotic speech. We call it as robotic speech. Some toys and all you might have seen that. The cat toy is several Tom, that kind what is called talking Tom. Those kind of tools, toys, you might have observed that. That's a robotic speech. That is totally generated based on the common frequencies. To produce more, what are the common frequencies? Use them and generate a signal. That way they do. So that's what these are different methods. Format synthesis, what I said is same thing. Then concatenative synthesis. Let us not worry about these things more. What is slide number 57? Voice is a biometric. Already we have spoken many things about this. Speech enhancement also I said, removal of noise. We will come to will you be able to play that? Just click on that. Speakers are connected to this? Yes, sir. Left side one you can play. Which language is this? You understand the list? What does it mean? One more. One more time we can say. తల్లిదండ్రులను గౌరవించవలెను. తల్లిదండ్రులు గౌరవించు. Yes. Respect your parents. And respect the parents. Respect your parents. These are called as emotionally neutral text. Text will not show any emotions. If I say happiness is shown there. Here, text is neutral. So you can play different things. First one is first one, whatever she has. First, did you play the top one? First one. That is anger emotion. Second one she has shown is disgust. You okay. Next you play some one or two more. It is fear. Next. Happiness. This side you are you hearing? That is some features we extract from this speech signal. After that, your vocal tract information is removed from the speech signal. Means whatever the signal is there when it reaches your throat, that signal we extract in the speech. Normally speech modulation happens if there is a vowel. After articulation of all articulatory organs. But if you extract it here, it looks like a whisper. Whisper. That is the right side. I think you are not able to hear to that. Something are you hearing? You are also not hearing liver. Don't worry about it. So these are some such features. These are called as glottal volume velocity. What features we can extract? That I am telling. Glottal volume velocity means how much air flows through the glottis through the mouth while you use the speech. If lot of air comes, then speech quality will be different. Less air comes, speech quality will be different. Continuously air is coming, even though vocal cords are closed, there will be creaky voice. Something like that. So, time is over. So these are spectra. Spectrum I said no previously F1, F2, F3. So these are different spectra for different emotions. Same person speaking, same word speaking, but different emotions. So formats will change. So these formats can be used to identify emotions. That's what my aim of telling this. So here you see this is speech signal, and this is energy. Energy means amplitude. If speech signal is not there, energy is zero. In case of vowel regions, energy is high. In case of noise, energy speech, energy is low. These are pitch contours. This is down, decreasing pitch contour, increasing pitch contour, pitch values do not remain same. Whenever I am speaking, sometimes pitch values, number of times vocal folds vibrate, goes down, sometimes it is more, this without my knowledge. So whether it is increasing, decreasing, if we ask questions, this speech profile will be different. If we answer, pitch profile will be different. Based on that, we will be able to understand the things. These are all the similar things. Personality features for different emotions. Okay. So, any questions? A quick question. Otherwise, what we will be doing is how to expand pitch, how to expand energy, those kind of things we will see. First, we will give a demo. Then, if you are interested, one experiment you should do. But it will be difficult as you are not experts in that area. But now, majority of speech processing tools will have their own functions. And you know, for purpose we will be using that. All those functions we can fix that. And want to write your own functions, you can accept whatever you want. Set number.